folks, Ms. Gosling here. This video is your introduction to our magnetism unit. By the end of this video, you'll be able to compare and contrast electric and magnetic fields. So we'll be able to talk about electric and magnetic fields and forces, some of their similarities and some of their differences. So let's start by talking about what magnetism is. So a magnetic force is a force that is caused by moving charges. And there are a couple of forms that this can take. So first of all, we could have our nice, simple, single charge moving along with some kind of velocity. And that charge is going to have some kind of magnetic field. However, as you remember from our electricity unit, if we get a charge that's moving in any way, what we have is a current. So we can have a force caused by a single moving charged ion, so something like an electron or an alpha particle, something like that. We can also have a magnetic force that is caused by a current in a wire. There is a third option, however, for magnetic forces and magnetic objects, and that is something called a permanent magnet. And a permanent magnet is probably what you think of when you think of a magnet. So a permanent magnet is something that is always magnetic. So for example, we have our bar magnets with their north pole and their south pole. You also would have something like a horseshoe magnet, which of course is going to also have a north pole and a south pole. And something like your nice kitchen magnet, which will have a north pole and south pole. We're not going to talk too much about how those work. So here are your three kinds of magnet. You have your moving charge, your current, and your special permanent magnet. And permanent magnets are just made from materials that are permanently magnetic. So they are always going to have a constant magnetic field, which is super cool and super weird. One thing that's important to know is that if a magnet is caused by an electric current, then that magnet is known as an electromagnet. So both of our first two examples, with our moving charges and our currents in wires, were electromagnets. And electromagnets are interesting in that they are not necessarily permanent, because as soon as that current goes away or changes in any way, that magnetic field is going to change. So one thing to know about an electromagnet is that a changing current results in a changing magnetic field, which means that they can have some special properties where we can change the direction of the magnetic field and use that to, for example, create motion. We're not going to, again, get too far into this, but one thing, again, but the important takeaway here is that we can differentiate between traditional permanent magnets, the kind of thing that you remember playing with as a kid, and electromagnets, which are caused by currents and are a little bit different from what you might be used to. So let's go ahead and talk about electricity versus magnetism, because we've been talking about charges for both of them. So similarities here. Both electricity and magnetism, we need to talk about electric fields and magnetic fields. And in fact, when we talk about magnetism, we are pretty much solely going to be talking about magnetic forces arising due to magnetic fields versus actually calculating the magnitude of that field as we did in our electricity unit. So another interesting thing about electricity and magnetism is that they can be attractive or repulsive forces. So as you remember, gravity is really only an attractive force. Any two objects with mass are going to be attracted to one another. However, for both electricity and magnetism, we have two different kinds of force interactions. So with electricity, as you may remember, if we have two different charges, so positive and negative, those two charges will attract. And if we have two like charges, so positive and positive or negative and negative, those two charges will repel. Magnetism is similar. If we have a north pole and a south pole of a magnet, then those two parts of the magnet are going to be attractive to one another. However, if we have two north poles or two south poles, then our magnetic force is going to be repulsive, and the two magnets will move away from each other. You can see this if you're looking at permanent magnets. You can see this with bar magnets. If you have the two north poles facing each other, you'll feel them pushing away from each other. And if you have the north pole and the south pole facing each other, then they will clack together. So another interesting thing about electricity and magnetism is that both of these forces are carried by electrons. And that is because electrons are our easiest charge to move. So when electrons move, when they go from one position to another, that is going to cause a magnetic field. When we have something that either has more electrons than protons or fewer electrons than protons, then that is going to cause an electric field, regardless of whether it's moving. So that brings us to our differences. When we talk about electricity, we are talking about static charges. So we're talking about charges that are not moving. And now electric fields can cause charges to move, but electric fields are not caused by moving charges. And that is going to be our big difference here, because magnetic fields and magnetic forces are caused only by moving charges. So if I have an electron that's standing still, that electron has an electric field but does not have a magnetic field. Once it starts moving, however, it is going to have a magnetic field as well. So another really important thing to know about magnetic forces that's different from both electrical and gravitational forces is that magnetic forces only work on perpendicular currents. So if I have a magnetic force like so, and I have a current that is in the same direction as that magnetic field, there's not going to be any force on my current. So the blue line is my magnetic field, the red line is my current. There's not going to be any force acting on my current because it is parallel to that electric field. However, if I were to draw my current perpendicular to the field, then that field could suddenly start doing work on it. And again, this is a really significant difference from both electrical and gravitational forces. And that is because an electrical charge does not have a direction, right? Charge is something that is a scalar product, whereas a current is going to be going in one direction or another, and the direction of that current is going to affect the force that is felt. Finally, our last significant difference is that there is no such thing as a magnetic monopole. So what I mean by that is with electricity, I could have a single positive charge or a single negative charge, right? That's my proton and my electron. In magnetism, on the other hand, every single magnetic field is going to have, and every single magnetic object is going to have both a north pole and a south pole. So I cannot have just a north pole or just a south pole with magnetism. We have to have both, and that's going to be a really key difference between electricity and magnetism. So let's talk takeaways. First of all, magnetic forces act on moving charges. And secondly, electric and magnetic forces are closely related to one another. Although they are different, they have a lot in common in that they both are affected by and are caused by and affect charges.